I go by Q. I'm an assistant professor in the School of Construction Management Technology at Purdue University. So it was just a little disclaimer before anything that I present here. So it was starting from the TOM project, the course that couple faculties are teaching in the school. There's a BIM related, computer vision related, and smart infrastructure management related. So those two students or main carrier, they lifted heavy things mainly. And the three advisors, including me, Q, we help the student to move the ideas forward. So the topic that I would keep explaining today is about the proof of concept. So it's the feasibility of framework that can integrate AI-based large language model reasoning into BIM workflow for design automation. So it's very hot topics. I know BIM is a very important things in our there's a little legs. Industries. I'm working in electrical contractors over the summer as a faculty externship program. I'm looking at how they work and the BIM coordinations. And the electrical contractors, they develop the BIM from the scratch, maybe sometimes from the general contractors. But you can see the conduit is all covered, but how detailed they work on the BIM model is they are also looking at the fittings. So the conduit is 8 feet standardized in the United States. And if you're connecting those two conduits, there's fittings. So the electrical contractors also looking at, they are modeling that fittings in the BIM models, that much details. So the BIM is a game changer here, but the thing is, it's very complicated. I mean, if you can add details into the BIM model, which is good, but it also adds unexpected complexities that can be resolved later in different coordination stages. And also there's very repetitive tasks. So you see a lot of conduit pipelines and mechanical systems, the duct and so on and so forth. And if one of the subcontractors move the element here and there, and the other coordinators, they need to move here and there, the element here and there. So it's very repetitive tasks. So the students and the research team wanted to see if there is a feasibility things that can integrate AI. If we say, oh, typing in the large language models and create the buildings, create the walls, create the windows in the BIM model, how can that work? So we wanted to see that in the large language models. So we did a literature review. One of the very interesting things is developed by the researchers in Korea, and they integrate add-on stuff to Revit model. And actually by saying it, the speech to BIM application. So say the add in the element on the existing wall, then the framework that they developed is interpret what was input, fill up, matching, and so on and so forth. And they actually do the execute in the model and the recheck and so on and so forth. So our actually work was very straightforward. How many of you actually know the cloud? I see, yeah. Cloud is the tool, AI tools that can multimodal tool, AI tools that translate the language to understand the scenes, the screens to see the manipulate the mouses or some applications that's showing on the screen. So we use the cloud to complete the simple task like, create the rectangular rooms with the 4 walls. So 6 meters long, 4 meters long, 4 meters wide, and the thicknesses of the walls. So let's see how it works. So we didn't do anything. We just used the cloud and asked the cloud to complete the task that we asked to do. So you see the screen on the left-hand side is the chat box that we put exactly same phrase that I showed here. On the right-hand side is showing the screen that the cloud actually reads. The program that we set is a FreeCAD in Linux-based the operation systems. So what you see here, the first error occurred and the program shut down and the computer is trying to reopen the FreeCAD in Linux systems. But, and I'm gonna for this one. So the software, not the software, sorry, computer reboot the program, the FreeCAD, and try to open new project and set the default planes and ended up with errors. So the main things that we encountered with this error was because the lack of tokens. Tokens, the large language model need to use to put the comment. So we did multiple times with a little different settings and a little different fine tunings. So it works. Still, we didn't do anything. We just used the cloud AI, changed different the settings, and this time it worked. Didn't have any, oops. Oh, this one, sorry. It worked. So this time we tried a little different. So we create one wall as a reference and ask the computer to generate the walls to the same size that I asked the previous slide. But this time it got messed up. It worked. It didn't crash the software, but it got messed up with the different component. The wall should be connected to the edge to edge, but apparently it's not. All right. So this is the end of the process. With the comment that I asked is exactly the same things. So create 8 meters and 4 meters wide rectangular walls with certain thicknesses. So this is the starting point that we do. We did this research. So as I explained, the platform that we tested is the FreeCAD in the Linux space. And what we did, we looked at the BIM domain knowledge, and also we looked at the FreeCAD integration layers. So we convert those knowledges and layer the UI, the UX systems into the code to integrate with cloud AI workflows. So in this framework, in this flow chart, the gray boxes represent how the default cloud AI process the large language model to manipulate the screens, whatever screens that they see. This time it's a FreeCAD platform. But the blue boxes, that's where the study contributed to. So as I said in the previous slide, we looked at the BIM domain knowledge and the FreeCAD, this software integration layers of where the menus are, how the menus works, and so on and so forth. So we put those BIM knowledge here. For instance, the window should be attached to the wall should be attached to the floor, and so on and so forth. That's very simple, the reasonings, but we created. And did we actually wrote that code one by one? No, we asked AI to generate it. So we didn't do much, but we double checked if it is correct or not. So we asked AI to create this code to use the BIM domain knowledge. And also this one, integrate, the FreeCAD integration layers, also how the menus works. And after that menu, where the computer should look at. So also we asked the computers to generate this code. So again, we added to the boxes in the Cloud AI default flowchart. And this is the result of the study. So we asked exactly the same things. Create the rectangular rooms with the 4 walls. The room should be 6 meters long, 4 walls width, and a certain thicknesses. So the users actually can see the Python consoles that how in the default, the cloud AI manipulate the mouse. Then there's no way that the users can see where the mouse, well, now they can. But in the previous last year, we couldn't see the mouse moving and where those steps are in the process, in the middle of the process. But this time, the software, the Python console shows where the domains, which part of BIM knowledge use this software, and also the integration layers as well. So in the chat box, we asked that to create the 4 rectangular the walls, first of all. And I'm gonna move forward. So it shows in the step-by-step, it shows the thicknesses and size of the walls that the created in the FreeCAD. And it looks like it's a disconnected, but actually it's connected in the element. And it completed the task with the 4 completed walls and attach each other. So yeah, it's very simple. It's not rocket science, but at least the computer can create understand the task and start the beginning with the scratch to the end. And also the users were able to see what kind of things were happening in the software once the beginning, the initial command was provided here. So the element selected, element moved, coordination was provided in the element, and so on and so forth. All right, so we compare the original framework. It's no manipulations, just cloud AI and enhanced framework. And the significant findings that we identified as a token used during this simple task, the token used with the original framework was really high. It's more than 130,000 tokens, and it got like 40 to 45% reduced. So here's the summary: 40% reductions in token usage, and also the required time and improvement, the result, and so on and so forth. But see, the limitations are this: we tested these systems and framework with a very simple task. Just 4 walls and create it together. If we use that framework for the little more complicated systems, like create a window on the existing walls, this side, that side, that might be really challenging. So future works is related to the limitations. We want to continue this path to see how the AI can help to make automated AI flow works. All right. That's all I have.